Hello everyone, my name is Leonardo Bozzoli, and today I'm gonna give you a brief introduction of the LCA methodology, followed by an example, a simple example. So, first of all, what is it? The life cycle assessment methodology consists on the compilation and evaluation of the input, output, and the potential environmental impact of a product system or a service throughout its life cycles. For example, if we consider the life cycle of a pen as a product system, we need to consider the materials needed for its production, also the energy used for the production of the pen, and once the item reaches its end of life, also the disposal of the item must be considered. The LCA methodology is divided in four main phases. The first one is the goal and scope definition. The second one is the inventory analysis. The third one is the impact assessment, also called LCA. And the fourth one is the interpretation. The first phase, the goal and scope definition, is divided in the definition of this goal, that is the definition of the intended application, the reasons for carrying out the study, for example, a lacking in the literature, a fast-spreading technologies, and so on, and the intended audience, like, for example, researcher or stakeholder, and so on. In this first phase, there's also the scope definition, where we have to define the product system we have to study, so the object of the study, the functional unit, so the quantification of the object of the study, on which the input and output are related, for example, one pen, and the system boundary, that consists on the definition of the unit processes to be included in the system. The following step is phase is the inventory analysis, in which there are two main steps here, the collection and the calculation. The collection consists on the collection of the energy input, raw material input, and all the physical input for the production of the product system. The collection of products, coproduct and waste, and the collection of all the emission to air, discharge to water, and to soil. Indeed, during the life cycle of a product or a service, energy and materials are required as input, product and emission to air and to the environment, more in general, occurs. In the collection phase, all the data collected refer to a certain amount of material or emission to air, for example, a certain 1 kilogram of raw material as input, or 1 kilogram of CO2 as emission to air, and then we need to relate the data collected here to our functional unit. In this way, we obtain the input and output related to the object of the study. The third phase is the impact assessment phase. Here, we have to select the impact categories, the category indicators, and the characterization models. Like, for example, we can see in the following slide what I mean. Then there's the assignment of the LCI result to the selected impact categories, called classification. And last, there's the calculation of the category indicator result, characterization. As I've mentioned, here we can see an example of the climate change as impact category, and we can see to what refer each term in this example. Let's go back to the previous slide. In this phase, we have to select the categories we want to consider in our study and relate the impact of each elementary flow to the impact category selected. Finally, we have to sum the impact that each elementary flow has on the different impact categories considered, and to find the final category indicator result. Here we can obtain either midpoint indicators or endpoint indicators, depending on which method for the impact assessment we have selected. Indeed, there are several different methods for the impact assessment. And in this slide are shown two of the most used impact assessment methods that are the CML 2002 and the recipe. And here are shown the impact categories considered in each impact assessment method. We can see that both present midpoint impact categories, while only recipe present endpoint impact categories. As I've said, these two are not the only two developed impact assessment method, but there are several of them, as reported in this slide. The following phase is the fourth one and the last one, called interpretation. Here, the results obtained are interpreted and sometimes reviewed. The finding of this interpretation may take the form of conclusion and recommendation for decision makers. As I've said, sometimes the interpretation phase may involve the iterative process of reviewing and revising the scope of the LCA, as well as the nature and the quality of the data collected, in a way which is consistent with the defined goal and a sensitivity analysis on the main parameters and assumption. There are some ISO standard that describes the principle and the framework of the LCA, and the two main one are 14040 and the 14044. In this slide, we can see the scheme of the methodology, of the LCA methodology. Here we can see that it could be a cradle-to-grave approach. That means that we consider the entire cycle, life cycle of the product system. Or we can also use adopt a cradle-to-gate approach, in which we neglect the some of the stages, like for example the end of life, or for example the use stage. In this general scheme, we can see different stages, like for example the raw material extraction or the materials or product manufacture, and each stage presents his input and output. Now I want to present you the application of a life cycle assessment methodology in a very simple case study, that is the life cycle assessment of a submarine power cable, concerning the production of the power cable. So it will be a cradle-to-gate approach. First of all, we have to define the product system, that is the 3-core submarine power cable with the XLPE insulation with a copper conductor. Then we have to set the functional unit. In this case, we set 1 kilometer of cable, and the system boundary, as we said, is a cradle-to-gate approach, where the phases considered are the raw material extraction, the materials manufacture, the product manufacture, and the transport between each phase. From datasheet, we collect the information regarding the material composing the 3-core submarine power cable. Then we have to proceed with the second phase of the life cycle assessment methodology. The second phase consists on the inventory of the input and output related to the raw materials, transport, and so on, regarding the production of 1 kilometer of cable. So, for example, we can use some free database, like for example ThinkStep, to download input and output of each product flow. For this example, we can gather information regarding copper sheet to get the information again of input and output of this product flow, instead of using copper wire for the sake of brevity. So we can download information regarding each product flow, dividing them and sorting in input material and input energy, and output to water, output to soil, and output to air. Both output to air and water present non-radiative and radiative output. Once gathered information regarding each product flow, we have to relate the elementary flows to the functional unit. For the third phase, we use the CML 2002 as an impact assessment method and its characterization factor. Once evaluated the impact of each elementary flow per category, we can find the total final impact through the sum. In this way, we can find the impact related to each category for the production of 1 kilometer of submarine power cable, considered for this example. The following phase consists on the interpretation of the result and in the review of the process alongside with the sensitivity analysis, if needed. This was a simple application of the LCA methodology applied to a simple case study. I hope you enjoyed the video.